Hello friends! Today I want to talk about fractions. A fraction is what we get when we divide a whole number into smaller pieces. So if I have one bar, let's pretend that it's a granola bar, and I want to split that granola bar into thirds and show 1/3 of the granola bar. I know I'm going to write my fraction as 1/3. The numerator tells how many pieces we're talking about, and the denominator tells how many pieces make one whole. So since the denominator is 3, I know that I need to divide my bar into 3 equal parts. And then it's 1/3, so I would shade in one of them. This is 1/3 parts. Now I can model that another way by using circles, like 1, 2, 3. This is a set of 3 cookies. If I want to show 1/3 cookies, then I shade 1 out of this set of 3 cookies. 1/3. 1 out of every 3. And we can actually show that with a larger, more difficult fraction if we say, how about 3 out of every 4? So if I show 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I want to show 3 out of every 4, 3/4, I can say 1, 2, 3, and then the fourth one is empty. 1, 2, 3, and then the fourth one is empty. 1, 2, 3, and the fourth one is empty because it's 3 out of every 4. So for every 4 pieces, we color 3 of them in. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3/4 is equal to 9 pieces. That's great. We've modeled these in a couple of ways now. So we have a bar model or a tape diagram, and we're using sets here that sometimes we can use circles, or you can have sets of whatever you'd like. We can show the fraction. Let's continue on with 3/4. I will use the fraction 3/4, and I'm going to decompose that into unit fractions. When we split something into fourths, each of the pieces that we're using is 1 unit. So in this case, if I have 1/4 plus 1/4 plus 1/4. This is a unit fraction because it has a 1 in the numerator. Unit fractions have 1 in the numerator. Those unit fractions are telling you that you only have 1 piece. If we have a composite fraction, 3/4 is also equal to 2/4 plus 1/4. In this case, 2/4 is a composite fraction because it itself is made up of unit fractions. I can do 1/4 plus 1/4 to make 2/4. So I can split fractions up into other groups of smaller fractions. And this relates to the regular math that we would do by saying, like 5, it can be made up of 1 plus 1 plus 1 plus 1 plus 1, or 2 plus 3, or 4 plus 1. It works the same way. So here we have now modeled our fractions in 4 different ways. Let's see. We can find equivalent fractions. So equivalent has the word equi in it. It sounds like equal. So equivalent fractions are fractions that are equal to each other. If I had the fraction 2/3 and I wanted to find another fraction that was equal to it, meaning it would be the same, I can draw that with a picture. Now, if I have thirds and I have 2 of them shaded, if I now double the amount of pieces by cutting each of those pieces in half, now instead of 2/3, I have 1, 2, 3, 4 out of 6. So 2/3 is the same as 4/6. That's great. I noticed when I did that 2/3 and 4/6 can be related in another way. Watch this. 2/3. If I multiplied 2/3 times 1 whole, then I would get a number that was equal to 2/3, because anything times 1 is itself. So what if I showed 1, but instead of showing 1 as the number 1, what if I showed 1 as 3/3? 3/3 means that there are 3 pieces in the whole, and I have all 3 of them, which means it's equal to 1. So I'll just stick that in here. So now when I multiply, 2 times 3 is 6, and 3 times 3 is 9. Ooh, now I have another fraction that's also equal to 2/3, 6/9. I can show that down here on my bar by taking the thirds and turning each, let's see, I have 6, so I'll take these thirds. I have 1, 2, 3, and I have 2 of them shaded, and I'm going to cut each of those thirds into 3 pieces because I multiplied by 3/3. So now I can see that I have 1, 2, 3, 4, 5, 6 pieces colored in out of 9 total pieces, and that's the same as the fraction that I got. The last way that we're going to model our fractions today is on a number line. When we make a number line, we have to include a few important things. Please make sure that your number line has arrows on each end to show that it continues in both directions. Start with 0 because I'm going to be modeling, let's say I'm going to be modeling 4/5. So 4/5 is less than 1, so I'm going to go ahead and put a 1 on the other end, which means that I need to have 5 hops in between 0 and 1. So in order to do that, 1, 2, 3, 4, 5, I actually have 5 squares on my graph paper here, but I want to show you what I would do if I did not have graph paper. I would find the middle, that's a half, and then I would find where 1/4 would be, and 1/4 would be about halfway in between the 0 and the halfway, so probably about right there. That's pretty good. And then I know that 1/5 is less than 1/4 because fifths are smaller pieces. It takes more of them to make one whole, so they're smaller pieces. So I know that my 1/5 has to be somewhere down around here. 1/5. Now I need to make my next hop about the same size. 2/5, 3/5, 4/5. Uh-oh, I ended up with 1, 2, 3, 4, 5, 6 hops. It didn't work. I can't leave it like this. I have to try again. I can either erase or try one more time to make my fifths. So I'm going to find halfway. I'm going to try about 1/4, make my fifths close to 1/4. Then I'm going to show 1, 2, 3, 4. This last hop looks a little big, so maybe I'd like to move it down a little bit to make it a little more correct. Now I can show 4/5 on my line. I start at 0, 1, 2, 3, 4/5, 1/5, 2/5, 3/5, 4/5, and I can stop right there at 4/5.